is most decidedly not an entrepreneurial company. It's Boeing. They've got a concept for a crew capsule, and they're partnered with Bigelow because Bigelow needs transport to their orbital habitats, and they're looking for someone to provide that. And Boeing is interested in leveraging any investment that they put in for ISS crew transport to support Bigelow as well. So I think in 5 years' time you'll see some decided advantages into that. But I think the one thing to keep in mind is there's an old saying is that we tend to overestimate what's possible in the near term and underestimate what's possible in the long term. I think that's certainly the first part of that phrase has certainly been true in new space over the last several years, because we've always thought that these new suborbital vehicles were right around the corner, just 2 years away. We've been saying that for much more than 2 years. Things do take longer. Once we get vehicles successfully entering service, provided that someone actually does make that happen, I think you'll see the pace of the industry really start to ramp up once people start to realize the possibilities of what these vehicles can do and what markets they can serve.
Thank you.
Well, I'd like to make a point that I think everything goes right back to basic physics. I don't think that there's anything past ISP. That's the whole secret. You've got to have ISP. You can't get it with chemicals. You're going to have to use isotopes. That's atomic power. Cheng Diaz can get to Mars if he's got a megawatt reactor in orbit in 6 weeks. I don't think you can have a spacefaring civilization on chemicals, and we just should forget it and go immediately to tapping the low entropy of the Big Bang and isotopes. The next step is chemicals. They stopped 40 years ago. They need to start now. Forget a little bit of radiation. We can tolerate a little bit of radiation. Hormesis concept, maybe it's good for you. I wouldn't go a long way on that one, but nonetheless, we just need to go back to nukes, stick to nukes, and go on from there. You want to get high speed. The reason jet engines have been successful is they can get high altitude. That's low drag. That's cheap. You've got to get rid of the atmosphere if you want transportation, and it's going to take ISP and high power to do it. I think we should just promote nukes. That's all we need to do here.
I'm always glad to hear somebody who agrees with me.
I think a better analogy here might be the Human Genome Project.
Yeah?
10 years ago, the government was going to do it in about 15 years. Private industry came along, did it in 3 years. Now we're doing it in 3 months. And we're doing it to a Neanderthal man.
Yes.
It took the ingenuity of the private sector to spur the government sector. The two go together. We need the abilities of both working together to get anywhere. And if we take the ingenuity of the various space program, the private space programs, Robert's ideas of getting to Mars, it's coming not from government but from the private sector. And I think the analogy of the airplane and space flight, I think we ought to look today's history and look at the Genome Project as a better analogy.
Okay, I have a question.
Getting back to our comparison with history, the Ortig Prize in 1919 eventually led to Lindbergh's flight, a transatlantic flight. The X Prize, more recently, led to the flights of Spaceship One. Do we need more prizes or incentives of that type, and if so, for what, and who would sponsor them?
I can answer that. The answer is I don't know.
Well, obviously in both aviation and now in space, prizes have played an important role. You know, the idea of making a lot of money doing what you love is great. They do it anyway, but if you can make a lot of money at it, it's great. The Wright brothers wanted to make a lot of money after they had invented the airplane, and the prizes encouraged people to go beyond perhaps seeing it as an avocation to a money-making vocation, which is certainly the X Prize with Burt Rutan going in that direction. I think, though, that prizes will only take you so far. The prize is a one-time windfall. I was hearing people earlier in the cocktail hour talking about you have to figure out how to make money from going to space. Come up with a business plan. Because by the time that Lindbergh makes his flight to Paris, you had the start of the commercial airlines. You had successful airlines running in Europe already. They were just beginning to run in the United States. There kind of was this sense of how one might make money from aviation. I don't think we have the same kind of solid idea of how somebody entrepreneurially might make money from space. Obviously, space tourism is one of the business models that's out there, but I think you need to have those folks who can figure out how to make it part of the economy, to commercialize it, and then you perhaps align prizes with that to provide the startup capital. But I think there has to be a larger idea in mind before the prizes are going to inspire a lot of things other than maybe one-shot wonders.
We're here to talk about how we want to go to Mars, but a desire to go to Mars isn't going to carry us very far. What will carry us very far is if we can offer the world something the world badly needs and which we can provide, and I have in mind energy. What I would like to do is see the power satellite become a mainstream source of energy. Why aren't we building power sats? They're too expensive. There is, again, the cost. What can we do to bring down the cost? Well, I've talked about some various possibilities, such as nuclear power. Certainly, when we have more energy than we can effectively use, that certainly is going to help to bring down the cost. So if we could do something like that, then we can talk about bringing down some costs and bringing in some new opportunities, and we will have the reason to do them because the world really does need new energy sources.
On the prize issue, you're seeing some companies sponsor prizes. Probably the best known example to people in this room is the Google Lunar X Prize. Putting a rover on the moon doesn't really necessarily fit into Google's long-term business plan in any way that I can really reckon, unless they really foresee a need of having rovers build the server farms on the moon. But they've gotten probably $30 million at least worth of publicity out of it. And so far they haven't paid out a dime because obviously no one's actually flown a rover yet. But the other source is the government. NASA for several years has had the Centennial Challenges program. They have done a number of prize competitions to develop innovative technologies from a new, more flexible astronaut glove to the Lunar Lander Challenge to develop autonomous landing technologies for future lunar landers. And you've had a number of businesses actually come out of those prize competitions. The person who won the glove challenge is a guy in Maine by the name of Peter Homer. He started up a company now to sell that technology to companies that build spacesuits, but other people who need other sorts of pressure suits as well, and need that sort of flexibility that the existing providers of such suits hadn't been able to provide. There's a company up in Seattle called Laser Motive that won one of the Power Beaming Challenge prizes last year out in California. And they are looking at ways of taking this laser power beaming technology to use, for example, to power UAVs. To basically have a UAV that could stay aloft in effect indefinitely so long as it's within range of the power beaming device. And certainly there are folks in Homeland Security and the DoD that are very interested in that, the ability to have effectively persistent surveillance from something like that. So that's something that they're going after as well. But the important thing that you see out of that is that the price can't be just sort of a technological stunt. It really has to be a way to focus attention on an interesting problem that has a business case behind it. The X Prize in space tourism really opening up the market for suborbital space tourism. Some of the NASA prizes. For things like Google and their X Prize, probably the business case isn't necessarily as clear, but there are a few companies that have been started to go after that market, thinking that if they can win the prize and demonstrate that they can put scientific packages on the lunar surface but at a much lower cost than the government mission, they'll have governments and perhaps others coming up to them and flying their payloads on future missions. But the important thing for any sort of prize competition is, don't develop a neat technology in isolation. It has to be part of a bigger scope of what you need and what sort of business you can make out of it.
Yes. We're talking, I go way back in the 60s, so maybe what I'm saying is too old. But anyway, I was in a Goddard Rocket Society years ago, and like when we were, like the woman from UD mentioned, von Braun, and of course the reason they got into space was a booster. And the thing is, you've got 25,000 miles per hour to get out of the Earth atmosphere versus 18, and all I'm hearing is the 18, it's like a barrier. You're hearing a barrier that you're stuck with the, I don't know if people agree or not, but I'm just saying, like on the space station and all this, it's not to get to the moon. It's not, I want to go to Mars and beyond, so to speak. So the point, what I'm getting at, what type of, in other words, you got a tremendous amount of load. And I mean, well, let me rephrase that. You need a huge payload for a small amount of load. Now, does anybody know the percentage of what you have to do to build a model, say on a lower rocket booster that could, say even be attached below a shuttle? That's just an example. Does anybody follow what I'm saying? Nobody's following it. Okay. We need speed, and we need to get as much mass wherever we're going, right? That's the problem. And we're not achieving it the way we're going, because we're building things that only go 18,000. They can't escape the Earth. And I'm saying let's concentrate more on something that goes at least past the 25,000 miles, barrier, and can go somewhere. Any comments? I guess I'm too old. Or maybe the idea is archaic, but I think that's the only way you can get to Mars is get that, get a booster or some type, be it, nuclear or whatever, to get, past this barrier. To me, I see that 25,000 miles and the load capacity is a problem, and it hasn't been solved as far as I know. So I'll just stop at this point. Anybody have any clues? Let me know.
I'm just worried, not a rocket scientist.
Back to the historic analogy. In the early 20th century, when the aerospace industry was starting, it was marked by a proliferation of dozens of different companies in propulsion, airframing, and the second half of the 20th century has been largely a story of consolidation. We're down to 2.5 major airframers, 2 primary propulsion companies, 1 large liquid rocket manufacturer if you don't count SpaceX. I'm curious if that is a flaw in drawing an analogy between early spaceflight and early aviation, and if the proliferation of new space companies perhaps is a bellwether to reverse that trend.
Well, again,